All right. Hello, students. Welcome back to TUTORhub, your e-classroom on YouTube. So today we'll be learning how to balance chemical equations, and this is the first of the series of videos where we will learn how to balance chemical equations. And today the highlight would be to teach you the MNO technique, which I observed works so well in balancing chemical equations. So I hope you're ready with your pens and papers so that we can proceed with our lesson today. All right. So before we proceed, please don't forget to subscribe to this channel. Click the subscribe button and the notification bell so that you will be aware of the next upload that I will be making in this channel. And also like the videos and comment so that I would know what topics you would prefer for our next videos. And if you'd like if you have any questions that you need clarifications or help with, then I can help you and assist you as soon as I can with the comments that you leave on the videos, right? So with that said, let's go to the heart of the video, right? So what is the MNO technique and how do we use it to balance chemical equations? So again, in general, if you watched my previous video about the nature of chemical equations, so you have AA plus BB forming CC plus DD, where the capital letters are your elements or compounds, your chemical substances, and the small letters are the coefficients that balances chemical equations. The MNO technique stands for the process on how we balance chemical equations. So what I found in my years of teaching is it works very well if when balancing equations, you first balance the metals on the reactant and product side of the chemical equation. And then the next thing that you balance are the non-metals. And the third and last would be oxygen and hydrogen atoms. Hydrogen, right? So by following the steps M and O, we will be able to have an easy time balancing chemical equations. And for sure, you would not hate this topic anymore. In fact, you will love this and you'll be able to teach this to your friends and siblings that you learned and mastered balancing chemical equations already. So are you ready, everyone? Again, like this video if you're ready. Right. Let's start with this very simple example. So the first thing that we notice is we have nitrogen and hydrogen reacting to form ammonia. And you notice that nitrogen is alone, right? It doesn't have any other elements attached to it. Same with hydrogen. It's also alone here, while on the product side, you have nitrogen and hydrogen together in the ammonia molecule. So how do we deal with this, right? N2 plus H2 to form NH3, right? Based on our rule, on the technique that I taught you, the MNO technique, right, begins by balancing metals. However, for this particular example, we don't have any metal in the equation. So we will be leaving it at that. We'll leave that step. Then the second step is to balance the non-metals other than oxygen and hydrogen. So our non-metal here is nitrogen. So we need to balance nitrogen first. In the reactant side, you have 2 atoms of nitrogen. In the product side, you have 1 atom of nitrogen, right? So what we do is we need to multiply something to the nitrogen on the product side so that it balances with the number of nitrogen on the reactant side. So how do we do that? So when we multiply this, when we multiply any number on the compound, the other element, in this case hydrogen, is also multiplied by that number. So going back, we have two nitrogen atoms in the reactant side and one on the product side. So we need to multiply two ammonia so that we'll be able to balance the number of nitrogen atoms in the reactants and products. So that's two nitrogens in the reactants and now two nitrogen atoms in the on the product side. Okay, so far our nitrogen atoms are already balanced. Okay, so we're done with this with the end step, balancing the non-metals. This time we'll balance the hydrogen atom. We don't have any oxygen atoms, so we'll skip that. And we'll balance the hydrogen atoms this time. Here we have two hydrogen atoms on the reactant side, and on the product side we have 2 as the coefficient with 3 as a subscript. So that's 2 times 3 multiplied by 3. You'll have 6 hydrogen atoms. So in this case, the hydrogen on the product side is much greater than the hydrogen on the reactant side. So in this case, we need to multiply something to the hydrogen atom on the reactant side for us to be able to balance the chemical equation. So what number do we multiply to hydrogen with a subscript of 2 so that we'll get 6 hydrogen atoms as well on the reactant side? Very good. That would be 3 because 3 as a coefficient multiplied by 2 as a subscript will give you 6 hydrogen atoms. So in this case, 1 nitrogen, we just leave it at that. 3 hydrogen atoms and 2 ammonia would be our balanced chemical equation. Right? So it's that easy, right? So following the MNO technique would make your lives easier. So does that make sense? If it does, leave a comment, like the video, and again, we'll have more examples here. So we proceed with the next example. This one, for this particular example, potassium chlorate and breaks down to potassium chloride and oxygen, right? So this is a decomposition reaction, and we have potassium here following our MNO technique, right? So in this case, potassium is a metal, and we'll look at it first, right? So in this case, AClO3, KCl plus O2. So potassium is a metal. We look at it first. Incidentally, it's already balanced, right? So we don't have any problem with potassium. The non-metals other than oxygen and hydrogen here is your chlorine. Chlorine on the reactant side is just 1. Chlorine on the product side is just 1. So it's also balanced. That's good. Then we proceed to the third step, the oxygen or hydrogen. We don't have hydrogen, so we leave it at that. And we only have oxygen atoms to balance for this particular equation. So on the reactant side, we have 3 oxygen atoms. And on the product side, you have 2 oxygen atoms. So what coefficient do we multiply on the reactant side and on the product side so that we'll have the same number of oxygen atoms in your chemical equation on the reactant and the product side? Okay, if we multiply the reactant side by 2 and the product side by 3, we multiply 2 as a coefficient to 3. That makes our oxygen 6. We now have 6 oxygen atoms and 3 as your coefficient multiplied by 2 as your subscript gives you 6 oxygen atoms on the product side. So here, you now have a total of 6 oxygen atoms, and that balances the oxygen atoms in the equation. The thing is, by multiplying this by 2 and this by 3, you disturb the original balance between potassium and chlorine in our previous steps. So what we do is we revisit it. In this case, you have 2 potassium atoms on the reactant side and 1 potassium atom on the product side. So how do we balance the potassiums on this chemical equation? So if we multiply the potassium on the product side by 2, you form 2 potassium atoms, and that balances the potassium on the chemical equations. Similarly, because we multiplied 2 to potassium chlorate, then we also multiply 2 to the chlorine on the reactant side. Incidentally, the 2 multiplied to potassium chloride on the product side also is multiplied to the chlorine on the product side, right? So that makes your 2 chlorine and 2 chlorine balanced already. So in that case, our balanced chemical equation would be 2 potassium chlorate forming 2 potassium chlorides and 3 oxygen atoms, right? Sounds fun, right? So this is how easy balancing chemical equation is. So just following those steps would make our lives easier. So don't forget to subscribe, like, and comment, but don't leave yet. We'll still have more examples in the coming here in this particular video. So hang on. I'm just reminding you to comment, especially if you have any questions about this particular topic. So now we move to our next example. You have sodium chloride plus fluorine forming sodium fluoride and chlorine gas. Okay, so in this case, we follow the steps MNO, and because sodium is a metal, excuse me, we balanced it first, right? We need to balance our sodium first. So that would be Na. It's just 1 and 1. So our reactants and products, Na is 1, Na is 1 for the products. Okay. Then, so we're done with the metal. Then the non-metal other than oxygen and hydrogen is or are your chlorine. So in this case, the chlorine on the reactant side is 1. The chlorine on the product side is 2. So we need to multiply this by 2 so that this balances out, right? So our chlorine now is already balanced. We'll go back to our sodium later. Then we balance our fluorine here because this is our next non-metal that's to be balanced. So we have fluorine, that's 2 for the reactant side and 1 for the product side. So we multiply this by 2 so that we'll get 2 fluorines and 2 fluorines. So that makes our fluorine atom balanced. But by balancing the nonmetals, you notice that we also multiplied 2 to our sodium atom on the reactant and product sides, right? So that balances our sodium to 2. Therefore, our balanced chemical equation is 2 sodium chloride plus 1 fluorine plus 2 sodium fluoride plus chlorine gas. So this would be our balanced chemical equation already. Okay? Does that make sense? So you have 2 sodiums on the reactant side, 2 sodiums on the product side, 2 chlorines on the reactant side, and 2 chlorines on the product side, 2 fluorines on the reactant side, and 2 fluorines on the product side. So that's our balanced chemical equation. Next, we have hydrogen plus oxygen forming water. So we have the MNO steps again. We don't have a metal, we don't have non-metals other than oxygen and hydrogen. So we go directly to balancing oxygen and hydrogen in our chemical equation. So if you notice, H2 plus O2 to form H2O. You have on the reactant side, you have two hydrogens. On the product side, you also have two, so hydrogen is balanced. For oxygen, you have two on the reactant side and one on the product side. So we multiply two to our oxygen to balance it out, right? But by multiplying two to our oxygen here, to our water here, you also multiply two to our hydrogen. That makes it 4. Therefore, we need to adjust our hydrogen on the reactant side by multiplying it by 2 so that we get 4 atoms of hydrogen on the reactant. So that balances the hydrogens and the oxygen on the molecule. Therefore, our balanced chemical equation is 2 hydrogen plus 1 oxygen to form 2 water molecules. Right? So we're getting faster because I know you're getting the hang of the MNO technique and you're realizing now most certainly that, oh, it's this easy to balance chemical equations, right? Now we're down to our last problem, last example for this part, right? And we'll have a series of videos discussing balancing chemical equations because I want you to master this particular topic, all right? So following the steps MNO, our metal here is lead, right? So if you have Pb, lead hydroxide plus lead 2 hydroxide plus hydrochloric acid to form water plus lead 2 chloride, right? So on the reactant side, our lead is only 1. On the product side, our lead is only 1. So that's pretty balanced. Then we have the non-metal other than oxygen and hydrogen, that's chlorine here. So the chlorine on the reactant side is 1. On the product side is 2. So we multiply this by 2 so that we balance the chlorines out. Then we balance our oxygen and hydrogen, right? So looking at oxygen first, we have 2 as a subscript of the oxygen of the OH. So that makes oxygen, there are 2 atoms of oxygen on the reactant side. And here on the product side, we only have 1. So to balance it out, we write 2 here so that we'll have 2 oxygen atoms balancing the number of oxygen atoms in your product and reactant side. For hydrogen, we have 2 times 1 for the OH, for the hydroxide ion, so that's 2, plus 2 for your hydrochloric acid, so that gives 4 hydrogen atoms. And you have, for the product side, you also have 4 hydrogen atoms balancing the hydrogen atoms in the equation. So you notice that if you start by balancing the metals, non-metals first, other than oxygen and hydrogen, you realize that balancing oxygen and hydrogen can follow easily, right? So that makes the process much easier, making balancing chemical equations so much smoother with this particular technique. So for this example, you have 1 mole of lead hydroxide, 2 moles of hydrochloric acid, 2 moles of water, and 1 mole of lead chloride as our balanced chemical equation. Wasn't that fast, easy, and fun? Right. So that ends our session for today. Don't forget to subscribe to our channel, like this video, and leave a comment or any question that you'd like so that we can clarify any concepts that you'd like to learn from TutorHub. And I'll see you in the next video. Happy learning, everyone, and have a great day ahead.